So now in these problems, we need to use the L'Hopital rule to approximate the limit here. And in order to use the L'Hopital rule, we need to check if it is indeterminate, if it is an indeterminate forms or not. So look at this. Cosine, look, this x approaches pi over 2 from the right-hand side. So in this case, cosine of pi over 2 would be, what is it? Very good. Cosine of pi over 2 is 0. Or if you don't remember, draw the unit circle here. This is the angle pi over 2. This is cosine axis here. At pi over 2, we project it to the cosine axis. And we see that, okay, cosine of pi over 2, it will be 0 when x comes to pi over 2. And the denominator, right? 1 minus sine of pi over 2. At pi over 2, we project it into the sine axis here. Sine of pi over 2 gives us 1, right? Therefore, the denominator becomes 1 minus 1, which gives us 0. So the form of the limit here is the indeterminate forms 0 over 0, right? So we can apply it the L'Hopital rule. L'Hopital rule. And the L'Hopital rule tells us that, okay, the limit when x approaches pi over 2 from the right-hand side of the function cosine of x divided by 1 minus sine of x is equivalent to the limit, the same, x approaches from pi over 2 from the right-hand side, and the derivative of the numerator, and divided by the derivative of the denominator, right? So from the L'Hopital rule, we have this one. So let us compute the derivative of cosine here. And what is it? Yes, derivative of cosine give us negative sine of x. Very good, thank you, Faith. And the derivative of the denominator here will be the derivative of 1, which is 0, minus the derivative of sine. Derivative of sine give us cosine, right? See? So it becomes the limit when x approaches pi over 2 from the right-hand side of negative sine divided by cosine, negative cosine, which is sine x over cosine x, right? Or we can write it as limit when x approaches pi over 2 from the right-hand side of the tan of x, right? Then this point, it is tricky. So can you guess where it is approaching to? Any guess? Don't worry. Okay, now remember the graph of tangent. If this is x, this is y, then the graph of the tangent will be like this. At 0, it is 0. It is negative pi over 2. And it is pi over 2. And the period of this is 1 pi, right? So in this interval, the graph of this would be like this. And the similar story, we have that the graph of this is like this. Okay, it's not a good graph, but you can imagine it. So here, when x approaches pi over 2 from the right-hand side, what is the value of tangent? According
Is
to
it negative infinity?
Perfect. It is negative infinity. Very good. So this is one way to get the result, right? But if you don't remember the graph here, how can we find it, right? So it's not too difficult. Let me show you the unit circle, as we mentioned many times in the class. This is the unit circle. Okay. Then here is the cosine axis, and here is the sine axis. And the angle 0 right here, and here is pi over 2. We are going to the negative direction, right? And here will be pi. We see that when x approaches pi over 2 from the right-hand side, it means x here. It should go from the right-hand side, means it's close to pi over 2 right here, right? It's going closer and closer to pi over 2 from the right-hand side. But we see that, therefore, the angle here is in the second quadrant, right? In the second quadrant, the tangent is sine of x over cosine of x, right? When x approaches pi over 2 from the right-hand side, we see that we project the value of this to the sine axis. It will be close to 1, right? You see it? You see it? And when x comes close to pi over 2, but from the right-hand side of pi over 2, it means larger than pi over 2, it should also be in the second quadrant. And when we project it here to the cosine axis, it will come close to 0, but this 0, the value should be negative because it is in the second quadrant. And here you see that the ratio 1 divided by 0, but it is a negative number. Therefore, it should be approaching to negative infinity. So that's it for the second problem.